So we're now going to do a little comparison and contrast between SpringWebMVC and SpringWebFlux, so you can kind of get a sense of an apples to apples comparison. And I'll be kind of focusing here on both the similarities and the differences between these two frameworks as they are provided with SpringBoot 2.0. So some things are very common. Both WebMVC and WebFlux can have controllers. They can also have reactive clients. You can also use other mechanisms that you may be familiar with, like Tomcat and Jetty and Undertow and so on. Those are things that you can kind of share. SpringWebMVC uses kind of classic imperative logic, the stuff that we've known about and worked on for a long time. No real surprise there. It's synchronous, therefore it's relatively simple to write and relatively simple to debug. And it uses, under the hood, you can use various persistent architectures like the JPA and JDBC and blocking operations and so on. In contrast, SpringWebFlux provides support for functional, or maybe a better word is reactive endpoints, using this expanded set of types called fluxes and monos. And it also provides a very interesting event loop concurrency model, which we'll look at in more detail in a moment. And under the hood, it can use a framework for doing fully asynchronous I/O called Netty, which is distinct from Jetty and Tomcat and other kind of app server-like models that are based on synchronous communication. Netty is asynchronous. So again, as we talked about before, WebMVC is synchronous. The client makes a request, and there's a synchronous communication that takes place in a request-response manner with the server, and there's a one thread per request model on the back end. And here's kind of a picture that shows how this works. Because it's a thread per request model, the clients make lots of requests. Obviously, the name of the game here to some extent is scalability. So you want to be able to support lots of clients pounding away on your web service architecture. And as the requests come in, there's a pool of threads where you only have a limited number of threads, of course, in the pool, but typically it's a large number, like a couple hundred perhaps. And each thread in that pool takes a single request and then does various callbacks to request handlers that then go ahead and do operations to blocking resources. For example, querying a JPA-based persistent repository. In contrast, WebFlux is asynchronous. So first of all, when clients make requests, they don't have to block waiting for the results to come back. Instead, those requests are sent asynchronously. The clients can continue on in their merry way. You'll get a lot more exposure to that when you watch the other videos that talk about asynchronous programming and reactive programming with things like Project Reactor's Flux and Mono, reactive types. And when the requests come in to the infrastructure that does WebFlux, there's basically an event loop, or there could be multiple event loops that are running with a pool of threads, and the number of threads in the pool is much, much smaller in the WebFlux model than it is here in the WebMVC model, where there's hundreds of threads. Here, there's typically about as many threads as there are cores, plus or minus a bit. And internally, because of the way that everything works under the hood using Project Reactor and reactive types, all the asynchronous processing that takes place, all the callbacks, for example, that are being done to do asynchronous operations are largely transparent to the server code, as long as you know how to write code using Flux and Mono reactive types. And as a consequence, you can have a very large number of connections, a very large number of requests running efficiently over however many cores you've got on that particular host computer. And the asynchronous nature of this whole thing just doesn't require as many threads to keep things going. Now, one of the other cool things, which we'll get a chance to look at later, is you can actually also leverage asynchronous database capabilities as well. And I'll talk a bit about that. That's not the focus of the moment, but we'll get to that. And so if you play your cards right and you have a client that's also capable of handling reactive types properly, you'll be able to get asynchronous clients, asynchronous servers, doing asynchronous communication, asynchronous computations, and asynchronous persistence access to data. And so the whole thing is just very, very scalable and works very well and takes really minimal amount of resources with respect to the number of threads in your thread pools and so on. So what happens here is you've got a pool of threads, but that pool of threads is much smaller, as I mentioned before. And so you have just a handful of threads that are processing all the requests asynchronously. And what happens when you do these requests? And again, you don't see this. This is hidden from you because it's part of the underlying infrastructure that comes with WebFlux. The thread, when you make operation calls, it registers callbacks and doesn't block. It returns right away. And when the results are done, then they're going to be sent back to the clients in all kinds of clever ways. So one of the things that's interesting about this is that you can use monos and fluxes to exchange HTTP requests and responses, just like you would with WebMVC. So that part should be old hat. It's just the programming model is very different. Now, there's other things that are worth knowing about here, and you'll get a chance to play around with this. I realize I've got my little face here over top of some of the code. Let me move it away. So when you take a look at things that are synchronous models, so you look at WebMVC, you typically would end up using REST template for that. And so if we take a look here, you can see that with, but when you're using the asynchronous stuff, the Flux, WebFlux, you use something called a web client. So from a client programming point of view, if you're sticking with WebMVC and you want synchronous communication from the client, you use REST template. But if you're doing asynchronous communication, you would use web client. This again assumes you've got a client that supports web client. Note, by the way, here, just a little side note, the use of auto-wired fields. So web client and REST template are both auto-wired, and they're created by the appropriate bean factor method. So looking at the REST template stuff first, that's what we've talked about before. This is interesting because you can make REST template calls on services, microservices in particular, that are in fact reactive, but you can treat them as though they are synchronous using the REST template programming model. So as you can see here, you do a REST template get for entity, you pass in essentially the URI and the URL portion of the service method you're trying to access, and you give it the type you want the result to come back as, which in this case is going to be an array of airport objects. And what's cool about this is you can program your clients, keeping in mind the client could either be like a web client, like an Android device or a web browser, or the API gateway portion of a multi-tier microservice-based architecture. And nothing changes at all on the server side. The server side can be purely reactive, but we can access it in a purely synchronous way using REST template. Now, what you can also do, if you want to, is you can basically convert back to a reactive type if you so desire. And this could be useful if you're dealing with platforms like Android, which, as I mentioned before, are not quite as full-featured in their support of reactive types as we might like. So what you could do is once you've got yourself, say, an array back, you could convert that into a flux with a little adapter, and then the rest of your code on the Android side could be happily working with purely reactive types, if you wanted to do that. In contrast, here's how you program with web client. So it's kind of similar. You have a web client, you say, I want to do a get call, or I want to do a post call, or whatever. You give it a URI, and notice how we're using the famous fluent interface style of programming here, where we're chaining together these calls. And then when the retrieve method is called, that's what's actually going to go ahead and kind of, that's the thing that when the asynchronous code starts to run, we'll go ahead and make the call to the server. And then what we get back from that will be a reactive type, and we can convert it, in this case, into a flux. So we'll get back a flux of airport objects. And what is nice about this is as soon as the responses are available from the server, they can be emitted. You don't have to wait for all of them to show up. You can get them back right away as they show up. And as I mentioned before, you can get this really cool support for end-to-end asynchrony. Again, assume for sake of argument that we've got a WebFlux enabled client that knows about reactive types. The client can be making asynchronous calls to the controller. The controller can be then forwarding to the service layer. That can be making asynchronous calls into the model layer. If you've got the asynchronous database types of mechanisms we talked about earlier, you can have the database be asynchronous. And nothing actually starts to happen until the client side calls a subscribe operator. When you start poking into reactive programming more, you'll see that there's this very powerful operator called subscribe, which is kind of like a terminal operator if you're familiar with Java streams at all. And nothing happens. Everything's lazy until subscribe is called. And once subscribe is called, then everything starts in motion and it all runs asynchronously. And there's thread pools in several places that are all handled magically, which is pretty cool. So what's important to note here, and this is kind of what I was talking about earlier, is that the JSON that's sent back and forth, which is actually what's flowing between the client and the server using HTTP, is identical. The JSON, the encoding, the decoding is identical for reactive, WebFlux, and mono types, as well as the traditional WebMVC ref types and list types. So if you were to look with some kind of network analyzer at the code that was flowing back and forth across the network here, you could see that it was coming back just the way you'd expect. You make a GET request, and then you get the flow of JSON coming back. The difference being that with WebMVC, all that JSON code will come back in one fell swoop, whereas with WebFlux, it'll come back sort of an element at a time, giving it more responsiveness. As a consequence, you can use tools, very familiar common tools like Postman, with either reactive endpoints or with the traditional WebMVC synchronous endpoints. And we'll demonstrate that later. So that's the end of the overview that kind of compares Spring, WebMVC, and WebFlux and tries to give you a better apples to apples comparison of how the two work.